Two-sum is the single most asked question in coding interviews, and almost everyone solves it wrong the first time. Not incorrectly, just slowly. In this episode, we start with the obvious brute force approach, see exactly why it breaks down, and build the hash map solution that interviewers actually want to see. Here is the setup. You get an array of integers and a target number. Your job is to return the indices of the two numbers that add up to that target. The problem guarantees exactly one valid answer exists, and you cannot reuse the same element twice. Simple to state, and that simplicity is exactly why it separates people who understand trade-offs from people who just know syntax. The first idea most people reach for is checking every possible pair. An outer loop picks a first number, an inner loop picks a second number, and you stop the moment two numbers add up to the target. It works, and it is a completely reasonable place to start an interview, but it is worth understanding exactly what it costs before we improve it. The outer loop walks through every index. The inner loop starts one position ahead and checks every number after it. The moment the two values sum to the target, we return their indices. It is correct, but for every single element, we are rescanning a large chunk of the array. And that nested loop is exactly where the cost is hiding. The brute force approach runs in quadratic time because, for every element, we potentially scan the rest of the array again. On an input of 10,000 numbers, that is up to 100 million comparisons. A hash map approach trades a little extra memory for a single pass through the array, bringing us down to linear time. That trade is almost always worth it. Here is the idea. As we walk through the array once, at each number, we ask a simple question. Have I already seen the value that would complete this pair? At index 0, we need 7, and we have not seen it, so we store 2 in our map. At index 1, we need 2, and 2 is already sitting in the map from the last step. That is the whole trick. One lookup replaces an entire inner loop. We start with an empty dictionary called scene. As we walk through the array, we compute the complement, the value, that would complete the pair. If that complement already exists in scene, we immediately return the stored index alongside the current one. Otherwise, we store the current number and its index for future iterations to check against. One loop, one dictionary. Done. Let's confirm it works with 2, 7, 11, 15, and a target of 9. The first number is 2. Its complement is 7, and scene is still empty, so we store 2 at index 0. The next number is 7. Its complement is 2, and 2 is already in our map. We immediately return 0 and 1, which is exactly the correct answer. The pattern here is bigger than this one problem. Whenever you find yourself checking whether a needed value exists elsewhere in an array, a hash map turns that search into a single lookup. You will see this exact trick again and again. Next episode, we look at concatenation of array, a short one to build comfort with array manipulation before we move into tougher problems. Subscribe so you do not miss it. See you in the next one.